Welcome to the deep dive. Today, we're tackling something pretty significant, a really potentially game-changing area.
hmm
It's the UK government's serious look at solar geoengineering, sometimes called dimming the sun.
Yeah, it catches the eye, that phrase.
It really does.
Hmm.
And we've got some interesting sources here laying out what they're planning, the science, and also the debate around it, which is quite intense.
That's right. And I think it's really important to get this straight from the start. This isn't about ditching greenhouse gas cuts. That's still, the main long-term plan.
Right.
Solar geoengineering, or SRM, solar radiation management, it's exploring a different angle. Basically trying to adjust the planet's thermostat, if you like,
Yeah.
by reflecting a tiny bit of sunlight back into space. It's kind of similar in a way to what happens after a huge volcano erupts.
Ah, right, the cooling effect,
Oh,
because of the ash and stuff.
exactly. Those particles high up reflect sunlight. So this is exploring if we can do something similar, but, deliberately.
Okay, so which bit of the government is actually driving this?
It's the Advanced Research and Invention Agency, or ARIA. They're the key player here.
All right, okay.
And they've put up some serious cash, 50 million, for this research.
Wow, that's not small change?
No, definitely not. And ARIA is interesting because it's modeled on DARPA, in the US. It's set up specifically to fund those high-risk, high-reward projects.
And tackling climate change certainly fits that bill.
Absolutely.
So what specific ways of dimming the sun are they actually looking into? What do the sources say?
Well, there seem to be three main techniques getting the focus. First is stratospheric aerosol injection.
Okay, sounds technical.
It involves spraying really fine particles. They mention things like sulfur, maybe calcium carbonate, way up into the stratosphere.
And these particles just bounce sunlight away.
That's the idea, like tiny mirrors reflecting some solar energy back out. But it's complex, getting the particle size right, the altitude.
Yeah, I can imagine. What else?
Second method is marine cloud brightening. This one focuses on clouds, specifically low clouds over the oceans.
Brightening clouds. How do you do that?
You spray tiny sea salt particles into them. Basically, clouds need particles for water vapor to condense onto.
Right, condensation nuclei.
Exactly. So if you add more nuclei, you get more water droplets. But crucially, they're smaller droplets.
And smaller droplets make the cloud brighter.
Yep. More smaller droplets make the cloud more reflective, so it bounces more sunlight back to space. It increases the cloud's albedo, basically.
Huh. Clever.
Yeah.
More salt, brighter clouds, less sun getting through.
Okay.
What's number 3?
Number 3 is cirrus cloud thinning. Now, this one's kind of the opposite in a way.
Opposite.
Yeah, instead of making clouds more reflective, this targets those really high, thin, wispy cirrus clouds.
Okay.
Those clouds actually trap heat radiating up from the Earth. So the idea is if you could somehow make them thinner or less widespread.
Then more heat could escape.
Exactly. Let more of that long-wave radiation, that heat, escape out into space.
So 3 different approaches. Aerosols high up, brightening low clouds, thinning high clouds. And ARI is funding research into all of them.
That seems to be the plan.
But why now? What's the big push?
Right.
Is it just that climate change is getting, well, scarier?
That's definitely a huge part of it. We're seeing the impacts ramp up, heat waves, extreme weather, and there's growing anxiety about hitting climate tipping points.
Tipping points. Can you maybe give an example? What does that actually mean?
Well, think about things like the big ocean currents, like the Gulf Stream system.
Okay.
A tipping point could be if that circulation dramatically slows down or collapses.
Right.
That would have massive consequences for weather in Europe, North America.
Wow. Okay.
Or like the irreversible melt of a major ice sheet, like in West Antarctica. That means serious, potentially rapid sea level rise.
Right. Things you can't easily walk back from.
Exactly. And the worry is that our current warming path makes these kinds of things distinctly possible. That's a quote from Professor Mark Symes at ARIA.
Okay. So the rationale for looking at SRM now is it might be a way to buy time.
That's the argument you hear. Buy time for society to actually make the big emissions cuts we need. It's sometimes called an emergency brake.
An emergency brake. And Symes says they need more than just models?
Yeah, he stresses moving beyond computer simulations and lab stuff to get real-world physical data to see if these things actually work and what happens when you try them, even on a small scale.
Let's dig into that science a bit more.
Yeah.
You mentioned the aerosol idea, mimicking volcanoes. How good is that comparison?
It's a useful starting point. Big eruptions like Pinatubo back in '91 did cool the planet measurably for a year or two.
Because of the sulfates they threw up?
Precisely. Those sulfate aerosols in the stratosphere reflected sunlight. So the idea is to copy that, but maybe, more controlled, maybe using different particles with fewer side effects than sulfates.
And the cloud brightening. Seems simple enough. Brighter clouds, cooler planet. Is it that straightforward?
Well, the basic physics is sound, yeah. More smaller droplets mean higher albedo, more reflection. But
But the effectiveness. That depends on a lot. Like what kind of clouds are there? Where are they? How well can you actually deliver the salt particles in the right size and concentration? Lots of variables.
okay. And the cirrus cloud thinning. That sounds harder. How do you even thin a cloud?
Yeah, that one's definitely seen as more challenging scientifically. It's a much earlier stage.
So how might it work?
One idea is seeding the clouds with specific types of particles, ice nucleating particles. The theory is this makes the ice crystals inside grow bigger, heavier.
So they fall out faster.
Right. Fall out as precipitation more quickly, thinning the cloud, letting more heat escape. But again, lots of research needed there.
Okay, so we have these three potential tools, all with major scientific questions still attached.
Definitely.
But like you said at the start, this whole area is incredibly controversial. Let's get into those debates and worries now.
Absolutely. Because while some scientists see this as maybe a necessary last resort,
Others are raising some serious red flags. A big one is just the risk of unintended consequences for the climate itself.
like what? Messing with rainfall.
Exactly. If you start reflecting sunlight differently, could that change weather patterns, shift monsoons, impact farming somewhere else in the world? The models suggest these are real possibilities.
And we don't fully know.
We don't fully know. There's also the whole governance problem.
Meaning who gets to decide?
Yeah. Who pulls the lever? If one country starts doing this, what about its neighbors? What if it harms them? There are no international rules for this stuff right now.
That sounds like a recipe for conflict.
Yeah.
Geopolitical tension.
It really could be. And then there's the big one, the moral hazard argument.
Ah, the idea that this lets us off the hook for cutting emissions.
Precisely. The worry is if people think there's a tech fix, like dimming the sun,
They won't bother with the hard work of switching off fossil fuels?
or at least the pressure might come off. Critics argue that putting big money into geoengineering might just give politicians an excuse not to tackle the root cause of the emissions.
That's a serious concern.
Yeah.
Is there a risk that message gets lost? The message that area says this isn't a substitute.
It's a huge communication challenge, for sure. How do you research this as a potential add-on without it being seen, politically or publicly, as the main solution? Very tricky.
And you see that unease reflected publicly, right? Didn't some comedian compare it to The Matrix?
Yeah, Steve Allen on GB News, apparently. And a U.S. Senator, Mike Lee, questioning on X whether we should trust the UK to dim the sun without, messing things up.
It taps into that kind of visceral feeling, doesn't it? About meddling with the planet on such a huge scale.
It really does. And some academics are very outspoken. Professor Mike Holm at Cambridge called the whole area program a dangerous distraction.
Strong words.
Very. He argues that money would be way better spent on clean energy or actual carbon removal. He basically thinks the whole idea of a planetary sunscreen is unsafe, ungovernable, undesirable, even breathtakingly naive. A false promise, he called it.
Wow. Okay, that's a powerful critique.
Mhm.
But there are other views, more nuanced ones.
Yes. Matthew Henry from the University of Exeter, for example, he points out, look, aerosol injection only works while you're doing it. Stop spraying, and the warming that was hidden comes rushing back fast.
Termination shock idea.
Right. But he also says, given how slowly emissions are falling, we need to investigate if this could be a short-term tool to shave off peak temperatures. And he makes the point that our climate models aren't perfect.
Yeah.
And small, real-world experiments like Area might fund could actually give us data to make those models better.
So improve our understanding, even if we never deploy it.
Potentially. And it's crucial to repeat what Area themselves say. They state clearly, this is not a substitute for decarbonization. That's the only long-term fix. Their aim is to see if these things could maybe lower temperatures alongside cutting emissions.
But even with those caveats,
Even with those, you get other senior scientists calling SRM barking mad. Someone in The Guardian apparently compared it to treating cancer with aspirin.
wow, treating the symptom, not the cause.
Yeah.
That really shows the deep divide here.
It absolutely does.
So given all these fears messing up weather, moral hazard, governance chaos, what are they actually saying about safety? How are they planning to do this research responsibly?
Well, Professor Symes at AREA has been quoted saying, everything we do is going to be safe by design. He talks about a commitment to responsible research, even if they do outdoor experiments.
What does that mean in practice?
Things like strict rules on how long experiments can last, making sure effects are reversible, and a promise not to release anything toxic.
And transparency.
They've said an environmental impact assessment will be published and local communities consulted before any outdoor work.
Okay, so they're trying to address the safety angle head on. But those big uncertainties won't just disappear.
No, they won't.
Stepping back a bit, how does this UK push fit into what's happening globally on geoengineering?
It could make the UK a pretty big player, actually. That 50 million is significant in this specific field. Global funding for geoengineering research is still pretty small compared to climate science overall.
Is anyone else in the UK doing this kind of thing?
There's another UK research council, NERC, the National Environment Research Council. They have a 10 million program too.
Oh, okay.
But theirs is focused more on modeling, using existing data, looking at natural examples like volcanoes. They're explicitly not doing new outdoor experiments.
Right. More observational and modeling based.
Yeah, and Kate Hamer from NERC stresses their job is just to provide solid evidence, not to argue for or against actually doing geoengineering.
Meanwhile, you have others, like Professor Jim Haywood, saying scaling this up could be feasible in maybe a decade.
Right, and that we need to look at everything, given how bad climate change might get.
But underpinning all this is that lack of international rules you mentioned.
Exactly. No global agreement on how to manage this if it were ever deployed. And lots of calls for a moratorium, basically a pause on actually deploying anything until we understand it much, much better.
And someone at Imperial College, Dr. Eastham, made the point that this isn't just science, it's international relations too.
Absolutely. He said deploying SRM will affect different countries differently, and part of the research has to be understanding those global consequences. He actually thinks the UK research might end up ruling out some of these ideas as just too risky or unworkable.
Interesting. So what happens next? When do we find out more about these area projects?
The area spokesperson said full details, which projects get funded, the timeline should be announced in the coming weeks.
So we'll need to keep an eye out for that.
Definitely.
Okay, so that was our deep dive into the UK's, well, really ambitious and, let's face it, highly controversial exploration of solar geoengineering. Quick recap. The UK, through AREA, is putting significant money into researching ways to potentially dim the sun, maybe even with small outdoor tests.
Yeah, looking at aerosols, cloud brightening, cloud thinning.
But it throws up this huge tension, doesn't it?
Yeah.
The potential lure of a quick fix for warming versus these massive risks, unforeseen climate effects, the moral hazard, global governance nightmares.
And the deep disagreements even among scientists about whether it's wise to even go down this road.
It's just fascinating, the sheer scale of what's being proposed and how much we just don't know.
Absolutely. These are not simple fixes. The ripple effects, good or bad, could be enormous and global.
Right. Which leads us to our final thought, something for you, the listener, to really think about. Given all these complexities, all the unknowns swirling around solar geoengineering, what ethical lines, what practical safeguards do you think absolutely must be in place before humanity even seriously considers deliberately tweaking the Earth's climate system like this?
It's a heavy question.
It is. No easy answers, but definitely one worth pondering as this research unfolds. Thanks for joining us for this deep dive.